สวัสดีค่ะสวัสดีค่ะ and good morning everyone. My name is ชนาการเติมวัฒนพัฒน์ and my nickname is Enya.
And my name is พีรดลกิจไพบูลย์พัฒนา My nickname is U.
Do you like to eat candy?
Yes, I love eating candy.
Do you know that candy consists a lot of sugar?
Well, yes, I do.
Okay, great. Because today we're gonna be talking about raw candy sugar. This article is one of the experiments meant to teach students how science is done. From generating a hypothesis to designing an experiment, or use this as an inspiration to do an experiment. Making raw candy at home is a tasty way to show chemistry in action. But the instructions contain a step that looks a bit odd. See, you're supposed to dip your stick into the sugar at the start of the process. Doesn't that seem like cheating somehow? And is it really necessary? It's easy to make raw candy. All you need is a lot of sugar, some water, and a little patience. Pour 3 cups of sugar into 1 cup of water and bring your mix to a boil while you stir. Once the mix boils, the sugar will dissolve into water. After a few days or a week, sugar crystals will have built up on the sticks, making a sticky, sweet candy. But the candy doesn't look like the sugar you started with. The sugar molecules have instead become highly organized into a crystal structure.
Wow, that's pretty cool.
A key step in this process is wetting the stick in the sugar. Clinging to the stick serves as a seed crystal. This is a crystal promotes the growth of the bigger crystals of the raw candy. Sugar molecules crystallize in a solution when they bump into each other and stick together. This first phase is called nucleation. Once a tiny crystal forms, it serves as a nucleation point. Other sugar molecules then glom onto it and make the crystal bigger. Seed crystals in the raw candy mix serves as this nucleation point, making the raw candy form faster.
How important are those seed crystals?
To find out, you gotta run an experiment. Every experiment starts with a hypothesis, a statement that can be tested. In this case, whether the seed crystals promote more raw candy formation. The hypothesis will be using sticks with seed crystals and sticks without. To test this hypothesis, you need 2 batches of raw candy. One is blue and the other one is red. The blue batch is going to be manual control, and the red batch will be the one coated with sugar base. To detect the difference, firstly, weigh both types of sticks. And then take the last half and dip the 12 centimeters. And then, at the end of the sticks, cling into the water and then roll them one by one in a small pile of sugar. Then set each aside to dry. Meanwhile, now it's the fun part. Bring 4 cups of water and 12 cups or 1.5 kilograms of sugar to the ratio of 1:3. And then boil in a pot and keep stirring and keep an eye on your mix.
What's gonna happen if you don't keep your eyes on the mix?
Well, it will boil very quickly, so it might get messy on the floor, you know? Then you have to clean it up, that's all. Well, anyway, once the solution is clear, add food coloring to get the desired color. Use blue for manual control sticks and red for seed-covered crystals. Use a measuring cup, pour 250 milliliters of the solution into each cup. Use a scale to find the mass of each stick in grams. Once you have noted the mass, dip the stick carefully in a cup of the sugar solution. and secure it in place. Make sure the stick doesn't touch the bottom or the sides of the cup. Make another batch of the solution. This time, coloring it red, and use the seeded sticks. Make sure to weigh each stick before dipping in the solution. Put all the cups to a cool, dry place where they will not be disturbed. After a day or so, you might be able to see seed crystals beginning to grow. The longer you leave the experiment, the bigger the crystals will get. But 3 days is enough to detect the difference. After 3 or more days, get out the scale again. Carefully crack the sugary film on the top of each cup with a spoon. Remove the stick in each cup. Then make sure it's not dripping and weigh it to find out how much rock candy you got in each group. Subtract the weight with the stick at the beginning of the experiment from the weight of the stick and the candy at the end. This gave a measure of growth in grams. Make sure to make a spreadsheet with the average mass of the crystals from both conditions. At the bottom of each column, calculate the mean average of the mass. For each group, the unseeded sticks grew 1.3 grams of rock candy on average. The seeded sticks, however, grew about 4.8 grams of rock candy on average. It wasn't a lot, but it definitely looked like a dessert. But were these two groups truly different? We need to find out. Needed to run some tests to interpret the meaning of the results. This is a test that finds out the difference between two groups. A p-value of less than 0.05 or 5% is considered by many scientists to be statistically significant. The Cohen's d for this experiment was 2.19. Generally, scientists count any Cohen's d above 0.8 as a large difference. So the difference was pretty large. Based on the results of the experiment, the graph showing that the unseeded sticks grew larger crystals than the unseeded sticks. This experiment supports that hypothesis. Thank you for listening. Thank you.